Hi, and welcome back to Programming for Biologists. Today we're going to look at strings and iterable objects. So, we will go back into Visual Studio Code. I have the notebook for session 4 open up here. So, what are strings? Strings are basically text. And they're text that your code recognizes as text, unlike comments. So if I define a variable here, so I'll just call it string1, and we'll go with the classic hello world. So this variable is now a string. So the code recognizes this as text, and this is text that we can then work with inside of Python. So you can use single or double inverted commas. So this is also a string. Now, I would try and stay reasonably consistent in how you use this inside your code, but ultimately it doesn't actually matter. It won't really affect how your code runs, and I'm particularly bad at swapping between the two depending on what I'm doing and the given day. It might also have something to do with which keyboard I'm using, actually. Anyway, so what we can do is have a quick look at another function. So we know print, and this allows us to print things. So we could just print string1, right? And we know that our string1 is equal to hello world, so when we do this, it prints hello world. But there's this other function called type. So if we put string1 inside of type, inside of print, and we run this, we can see that it prints first hello world, because we told it to print string1. And then secondly, it prints this class string. What this is telling us is that this variable is of a type or class of string. Now, if we were to do this on, say, just the number 1, and also 1.0, we can see that 1 is just an integer, class integer, and then this 1.0 is a float. And it's a float because it has this decimal place. Anyway, back to strings. So strings are text, and text is really important when we're doing data analysis because actually most of our data is stored in the form of text in one way or another. It's in some sort of file, which most of the code will just interpret as text, unless we use something fancy like pandas to import a whole table. We're mostly really dealing with text files. So strings are iterable. So what do we mean by this? So iterable objects in Python are basically things that we can address parts of. So if we take string1, for example, we can print either the whole string or we can just print part of the string by using an index. Now to index into objects inside of Python, we use square brackets. So in Visual Studio Code, if you just type 1 square bracket, it will automatically generate the second square bracket for you because it knows that you're probably going to want to write something between 2 square brackets when you start using square brackets. And then if we press 1 now, this will return the thing that's at index 1 inside string1. So string1 is hello world. Now, if you've used other programming languages, you might think that this is going to return H. But actually what happens if we run this is that we get E. Now, the reason that we get E is because Python always counts from 0. So if we type string1 0, we can see that we get H. Now, we don't just have to access single elements inside of our strings. What we can do is use semicolon to access multiple consecutive indexes. So if we were to put, say, 0 to 2, now this is also a bit of a trap because of how Python counts, but so we get H and E. So we get the first and second element of the string, and that's because when you're using indexes, the colon basically means up to this number and no more. So if we were to put up to 4, then it's going to give us the first 4 elements inside of the string. So HELL is the first 4 elements of string 1. And we can also do this for string 2 that we made, which was also a string, but then we could index from, say, 1 to 5. So we don't get the first A in also, but we get the LSO and then the space. And you can't see the space, but it is there. If I highlight it, you can see there's the space. So maybe it would have been more smart to go to number 6. Okay. So this is how we can access different things inside of a string. And at first, this doesn't really seem super useful, but this does teach you something about how iterable objects work in Python, right? So you can access individual parts of them. So one thing that we can do also in Python is count in reverse, which is a fun trick. So say we wanted to get the last element of this hello world, we could count and see how long this is and be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So then if we go to index 11, it's going to say there is no index 11 because remember that we have to count from 0. So actually the last element in string 1 is 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just fine for something that only has like 10 bits to it. What we can do in Python instead is just say -1. So what's basically the last element in the string, which also returns D. And we can do this reverse indexing just like we do forward indexing. So we could say print elements -3 to -1. And then we get the RLD. So in this case, we would just say to the end. So if you don't put anything there, then it will just go to the end of the object. The negative third index up to the end. Okay. So this is nice, but how does this help us? Well, we can break strings into lists. So a list is another type of iterable object in Python. And we can store lots of things inside of lists. We don't just have to store strings, but we can actually convert different types of objects. We can convert an object that is a string into an object that is a list. And lists in Python will always be printed with square brackets at the end. So anytime you print something out and it has square brackets at the end, it's a list. There are other types of iterable objects in Python, such as tuples. I'm not even sure if we can actually convert a string into a tuple because I've never thought to do it, but yes, we can. So we can convert strings into tuples as well, and these have round brackets at the end. Now, we can come on to the difference between strings and tuples at some point. Strings and tuples, lists and tuples at some point, but for the purposes of this video, they're very similar. The main difference is actually that you can change lists, but you can't change tuples after you've made them. Cool, so we can convert this into a list, and that's, also doesn't seem super useful because we could just index into this as we had before, and accessing all the elements in these converted to a list or a tuple would be exactly the same. So with list objects, you can do exactly the same thing. You can get the last element by -1, or you could get the first element by 0. But you can break strings into lists in multiple ways. So you don't have to convert them straight to a list. There is a really cool function for strings inside of Python called split. So I'm going to use our second string, also a string, for this. And different types of objects in Python have some built-in functions. So normally, up to now, we've used functions by typing them out and putting circular brackets like type or print. But some objects have built-in functions. So if we take our variable string2, if we type a full stop, we can see this list of things that come up now. And we can do all sorts of interesting things with strings. We could use lower, and if we print this, we can see that it returns our existing string all in lowercase. There is another function in here as well called upper, and that will convert a string to all uppercase. So there are lots of built-in functions for strings, and we will come on to more of these in later videos when we're making comparisons and learning about Boolean logic. It's particularly important when comparing things because Python will expect things to have the same case. So like if one thing's lowercase and the other thing is capitalized, Python will not see these things as the same. You will need to convert them both to lower or both to upper for it to make a correct comparison. Anyway, that was a slight segue. So the function that I actually want to talk about is called split. So we can type string2 again, and we can just use up and down arrows to select the variable that we want to use. And then if we type the full stop and then type split. Now, by default, this will split based on spaces. And actually in some files, this is actually super useful, because what we're getting here when we run split is a list where the list has each word as an individual element in the list. So split. So this is making a list now, and if we take the first element, then we get the first word. And if we take the element 1, then we get the second word. So what I will do is just print all these bits individually so you can see what's happening. So if we print the whole string, we have also a string. And then if we print the string split, then we get this list. And basically what I'm doing is, without saving it to a separate variable, is just accessing elements inside this list that we're generating. So when I run split, we're generating a list, which is just made out of this original string, also a string, and it's splitting it by the spaces. So the spaces are basically disappearing and becoming where we put the commas in our list. And then if we get the first element, element 0, that's also the second element, element 1 is A, and the last element, element 3 is string. Now this will become useful later, because CSV files, if you have comma separated files, This basically means is you have all elements inside a table, for example. So this could be like heading 1. Let's use some examples. So we could have gene name, comma, gene code, comma, expression level. And we might import this into Python, and Python would read the text as it is here. And we also have TSV files, which are tab separated files. And in code, we write tab as /t. So this is gene, tab, gene code, tab, expression level. Now we can use split to break these things up. So let me just run that to create these two variables. So we have CSV files, which is this set of commas. Now if we run split on this, it doesn't do anything, right? Because it normally by default splits by space. But what we can do inside here is give split a string. And string is a pattern to look for inside another string. So if we give it a comma, now it splits up our text by commas. So in theory, we could import bits of a CSV file and break them up. And then we could get, say, just the gene code by getting element 1. And as always, if we want to see everything that's happening inside these cells, then we need to put prints around them. Not the comment. Okay. So yeah, we can split up our CSV files by telling it we want this pattern with the comma, and then we can get the first element. And we can also do this with the TSV files. If you want to try this for yourself, then you can pause the video, but I'm going to go ahead and show you now. So you've been warned. So I'm just going to copy and paste this. I'm going to change this to a tab and access our string TSV file. And actually, I will run this with just the comma, for example, to start with. List index out of range. Okay, so what's happening here is I'm getting an error because it's saying there is no list object, and that's because it didn't split the list, right? So I've told it to print this TSV file, and what it's done, it isn't able to split it because I've just told it that I'm going to split by comma, and there is no commas in our TSV file text, right? It's just tabs. So now if we change this to a tab, we can see that it's split, and then we were able to access the first element, which was the gene name. Access the gene code and the last element. So I hope you can see how by being able to manipulate strings, it's actually super useful for getting data potentially out of files. And we will look at how to do this in upcoming videos. Okay, so I think this is basically where I want to leave you at the moment. Basically, one of the key skills you're going to need as a biologist programming in Python is being able to manipulate strings or any type of data analysis, because most of the files where data is stored are basically just text files. So I will do one more example, because okay, say this is like the first line of our TSV file. So we'll call this one TSV files line 2. So this could be a gene, and then a tab. I don't know what the gene code is, but yeah, something. And then we'll just say the expression level is like 2000. Oh, something a bit more interesting up. 2045. Okay. So what you will notice with this now is if we break this up using split. So it's a tab separated file, so we want /t. And then if we get the last element, so -1, this returns 2045. So just so that we can keep working with that, I'm going to take this last element in the TSV file, split, and assign it to this last element. So if we print last element now, this is 2045. But if we check what the class of this is using type, we can see that this is a string. Now, just as with being able to convert a string into a list, we can also just convert a string into a number. So we can convert, so we can print last element, but what we can do is we can wrap this in brackets with this int statement. So this int function converts strings to integers. And if we now check the type of this, so we're stacking a lot of functions inside each other. First, we're taking our string last element, which was the last element in this list, converting it to an integer, then we're checking what the type of that is, and then we're printing it out. And we can see that we're able to convert that to an integer. And we can also convert this to a float. So if it was if it had decimal places in this element, so say it was like 0.45. Let me just print these without converting them. Sorry, without checking what type they are. We do want to convert them. So we can convert strings to numbers, basically. And then that means that we can do maths with them, right? So we convert the last element. So first we just check what the type is. And originally it's a string, but we can convert that to an integer. We convert it to a float. Now, remember that integers don't store decimal places. So if we were to rerun this cell and rerun this, we're going to get this error. And it's basically telling us that it can't convert this string to an integer. And the reason it can't do that is because it has this decimal place. So we can convert it to a float because it has the decimal place. And then we can have this number now. And then we could do maths with this, right? So we could like -1000. Okay, so this is a good way of getting data out of files. I mean, there are better ways of getting data out of files, but I think for understanding the core functionality of Python, this is actually a good way of learning, and that is to manually access files and manipulate them. And there are some advantages to this, because this way you could take a file that's like 2 terabytes and you could get just the data that you want out of that file by reading through each line of text individually. And you don't have to load a 2 terabyte file into the memory on your computer. You could just read over each individual line, which will be very small, and perform operations on just that line of text, for example. Okay. Oh yeah, so one other thing just to point out would be that, so we've used these like fancy patterns, I guess. Well, not really fancy, but we use commas and tabs as separators. But if we were to take string 1, which we know is hello world, we don't have to split by a space. We don't have to split by a tab. We don't have to split by a comma. We could just say split by O. Okay, and now what it's done is it's broken the string up with everywhere there was an O, it's put a comma. And we could also say split by L. And that gives us an empty element because there's a case where there's 2 L's next to each other. But it doesn't have to be a single letter. We could say split by L. And then we've just got H, L, O world. We could split by LO space. And then we can say we've just got rid of the L and O off the end of hello world there. So this is actually really useful for extracting particular bits out of strings. Because it might be that you want to find particular patterns in a file name or something that's a bit odd. And similarly, you could, I don't know, biologists store files in all sorts of weird ways. So you could have an example where you have gene, comma, gene code, and then they'll have like extra information, and it'll be like blah1 space, blah2 space, blah3 space. And sorry, shouldn't be inside split. So you could have horrible file format. And if we were to take this horrible file format that we've created, which isn't that dissimilar to some file formats I've seen in the past, and just run split on it by comma because it's a CSV file, we've got this, but we're not getting out all these extra elements. So what we could do is take this, and then the last element, which is -1, and then we could split that again based on spaces. Then we can get those 3 bits out. And we might want to put all of this back together in some way at the end. Okay, so say we wanted to make this into like one list, right? I promise I will go over this more in future videos. But you can basically add lists together like the numbers. You can't do this with arrays. This is a very important difference, and we'll talk about arrays separately. But for lists, you can basically just join them by adding them. So, and also strings. So if we had this plus this, it just adds it together. You can add strings, but you can join them together just by using a plus symbol. So we've got this horrible format 1 that we've got here. And then basically we've added another one of those onto it. So we've got the whole thing twice. But what we can do is we can make both of these into lists, right? And then we've got the same thing listed twice. But what we want to do is get all of these bits into individual lists. So we know that we can take all the first few elements of this list. Maybe I should delete this just for ease of reading. So basically what we've got here is we want to split this list by commas. And then we've got the first 2 elements that we wanted, so gene and gene code. But what we also want is this last element, but we want to split this up separately. So we could take this horrible format file, imaginary file, and split it the same way. And then just take the CM, again using inconsistent inverted commas, but do as I say, not as I do, I guess. And we can get the last element of that. So that's -1. But we can split that up again. So we can split this last element by spaces. Obviously, this does that by default, but I'm just putting it in to make it slightly easier for you guys to read. What we can do is add these things together. So we have the first up to the last element. So this is gene and gene code, because this last element is just all of this from this comma. So we're counting by commas essentially. Then we're adding on to that the last element, which is this blah, 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 blah bit, which is this last element minus 1, and then we're splitting that up again, and we're adding it all back together. And by doing this, we can make all of these individual elements, which could be, say, columns in a table. And it's stuff like this that normal table readers might struggle with. Now, there are ways of just importing it, and what it would do is what we've done basically, divide it up by the commas, and you'd have this one column, and then you could split that column again into multiple columns. But you might not want to load all of the data, and basically the way that we play with strings here is useful for how we would import and deal with data in real life. Okay, this video I think has gone on long enough, and I've taken a few segues that I didn't intend on taking. But next time we will go more into lists, so more iterable things, talk about tuples, what they are, and also look at dictionaries, which are another cool way of storing data. So yeah, thank you for listening, and I will see you in the next video.